Hello everyone. So today let's solve the problem Duff in the army, right? So this was asked in the code forces round 3 to 6 for the division 1, rated for the division 1 actually. And this is going to be the last problem in this playlist. So this is the 50th problem, right? So as we had discussed, we'll be completing we'll be solving 50 problems in the that is completely based on the graph actually. Uh, yeah, we have implemented so many algorithms actually. We have learned so many things actually. And this is going to be the last problem, as I've said, right? As we had discussed actually. Yep. So let's continue with the same. So I'll just summarize the question. You can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. Let's see what the question states here. So there is a tree with n cities actually. Yeah. One second. Just give me a second here. One second. There is a tree with n cities. Yeah, there is a tree with n cities and m people. Yeah, there is a tree with this one n cities and m people. Person I lives in the city C of I. Yep. So that's the array C actually. For Q queries given V, U, and A, vertex U, and A. Actually, what we need to find, we have to find up to A smallest person IDs. We have to find up to A smallest person IDs that live on the simple path from U to V, that live on the simple path from U to V, right? So I can just write it like this, U to V. Yep. So we have to output K followed by the K IDs in increasing order. What we need to output here, K followed by the K IDs. Yeah. K followed by the K IDs that live on the sample path, by K IDs in increasing order. Yeah. So each A less than or equal to 10 accordingly with the constraints, A less than or equal to 10. And so we only ever need up to 10 smallest IDs per path. 10 smallest IDs per path actually. Yep. So this is fine, I believe. Yeah. Let me read the question loud. Just listen to this carefully, man. There is a tree with n cities and m people. There is a tree with n cities and m people. Person I lives in the city C of I, right? For Q queries given V, U, and A. For Q queries given V, U, and A, find up to A smallest person IDs. Find up to A smallest person IDs that live on the simple path from V to U. From this is actually from V to U, not U to V, this path, sorry. Let me write this one again. This is from V to U actually, not U to V, sorry. Yeah, that live on the simple path from V to U. So what we need to output here, we need to output K followed by the K IDs, K followed by the K IDs, yeah, in the increasing order. Each A less than or equal to 10. So we only ever need up to 10 smallest IDs per path, yeah, accordingly with the constraints actually. Yep. So this is fine, I believe. So let me delete this one. So this is the input output part. So this is the input output part. These are the edges actually. We have been given V, U, and A as well here. So the output total overall output that we need to get here is 1 3 2 2 3 0 3 1 2 4 along with the 1 2. Yeah. So here they have shown the graph as well. See here, graph of Andasgu in the sample cases as follows. They have shown here. ID of the people in each city are written next to them. So this is nothing but the ID. Yep. So these are nothing but the edges from 1 to 2, 1 to 3, 1 to 4 actually. Yeah. Yeah. 1 to 2, 1 to 3, 1 to 4, and 4 to 5 actually. So the IDs of the this one people in each city are written next to them in the sense this one. 2 is the ID. So basically next to 1, this one next to 2, 4 next to 3, 3 next to 4, and next this one 5. We don't have anything. This is fine. Yep. Now let's do one thing. Let's quickly discuss the approach followed by the complexities and then let's write the code. Yeah. Now we have the understanding of the question as well as the input output part. Let's do one thing. Let's quickly discuss the this one uh, approach followed by the complexities and then let's write the code. As usual, let's discuss the approach first. So here I have considered the same first example that I have given in the question. So the output that we need to get here is 1 3 2 2 3 followed by 0 3 1 2 4 and 1 2, right? So for this one, this is completely based on the LCA actually. Yeah, least common ancestor. Yep. So let's go with a binary lifting to solve this particular problem. Yeah. So just remember this, we'll be going with a binary lifting to solve this particular problem. The problem is completely based on the LCA, right? So let's move on with the step-by-step explanation here. So let's what the example input that we have got here, C it 2413 actually. C is nothing but the array C here. This one. I'm speaking of C. We have 2143. Yep. So person 1, city 2, person 2, city 1. This one I'm saying. Person 1. So this is person 1, person 2 to city 1, person 3 to city 4, and person 4 to city 3. So this one we have already seen the graph, right? So they have already mentioned the graph as well. 1 to 3, 1 to 2, 1 to 3, 1 to 4, then 4 to 5. Yeah. Next to that one, they have mentioned the IDs as well, right? First query, we have v equals 4, this one. Accordingly, with the input that we have considered v equals 4, u equals 5, and this one we are considering, right? So let's consider this query, and these are the adjustment. These remain same actually. These are the edges actually. This is nothing but the n basically. Yeah. So from 1 to 5 you can count. We have 5 nodes here. 1 2 this one 3 4 as well as the 5. We have 5 nodes actually. We have 5 nodes, and this one we have 4 edges actually. You can consider this one as m. Yeah. So this one we have 4 edges, 1 to 3, 1 to 2, 1 to 4, as well as the this one 4 to 5, and we have 5 queries, 1 2 3 4 5. This is nothing but the queries actually. You can consider this one nmq or nm queries for now. Yeah. So this is fine. These are nothing but the, again, these are nothing but the edges, and see, this is nothing but the array, and these are nothing but the queries actually. So we are considering only the query 1. So I'll just explain by considering the query 1 along with the this one edges. So you can just consider the same way, or you can, yeah, you can just consider in the same way, or you can just solve in the same way that I show for the that I show by considering the query 1. Yeah. So that you understand the problem even better, right? So this one P1, P2, P3, and P4, person 1 to city 2, person 2 to city 1. So this one person 3 to city 4, person 4 to city 3. So this is fine. Now the first query we have this one. In the question they have mentioned V, U, and A itself, right? So if you would have observed, I said that this one, what do we call? For Q queries given V, U, and A, right? So there is a tree with N cities and M people. We saw that one, right? In number of nodes, nothing but m, nothing but the edges, people. N cities, m people. N is nothing but the number of nodes, m is nothing but the this one edges actually. Person I lives in the city I said. For Q queries given v, u, and a, right? So this is nothing but that v, u, and a, right? So we have, for the first query v we have 4, u we have 5, and a we have 6. Yeah. So for the path 4 to 5, for the path 4 to 5 is node 4 comma 5 actually. For the path 4 to 5 is nodes 4 comma 5, right? So people on these nodes 4 and 5, I'm speaking of, right? Path we have got 4 and 5 here, is nodes 4 comma 5. People on these nodes, nothing but the person 3 at the city 4, person 3 at the city 4, right? So this 4 and 5 we are considering actually. Person 3 at the city 4. So the sorted smallest ID on the path is 3 actually. Yeah, person 3 on the city 4. The sorted smallest ID on the path is nothing but the 3, right? So we will be going with a k equals minimum of 1 comma 6. Min of 1 comma 6 is nothing but 1 here. So the output that we'll be going with here is this one. The smallest IDs on the path we got 3, and here minimum we got 1. So the output would be 1 comma 3. I mean 1 3 actually. Yeah. So this is the output that we got here. So see, we have got 1 3, right? Then next, let's this one continue with the second query. So second query, I'll show you for the first and second query. So this one 1 5 2 we have, right? 1 5 and 2 we have for the second query. So let's do the same thing, man. So for the second query, we have the path from 1 to 5, right? We have the path here. The path was from 4 to 5. A was equivalent to the 6 actually, right? So this is fine. For the path 1 to 5, path nodes are this one. What do we call? You can see here 1 5. You can look into the diagram or the figure that they have given in the question at the end actually. So the path nodes are 1 4 and 5. The path nodes are for this one. The diagram went like this, like 1 to 2 3 4 and 4 to 5. right? For the path 1 to 5, we have to go through the 4 actually, and then from 4 to 5, right? The path nodes are 1, 4 to 5. The same thing goes from here. But for this one, first query, we directly consider from 4 to 5. There is only one path. But from 1 to 5, a person has to move to 4, then 4 to 5, right? So the path nodes are 1, 4, 5 here. People to the person 2 here. People to person 2. This is fine. At city 1. Yep. Person 3 at the city 4. So id is equals 2 comma 3. Yep. Person 3 at the city 4. So id is 2 comma 3, right? So we will take the minimum of 2 comma 2. You can just consider any value, right? So 2 comma 2, we have equal value here. Minimum we will be considering 2 here. So the output would be this one, 2, 2 as well as the 3, 2, 2 as well as the 3. See here, that's what we have written. That's the output that we got here, basically 2, 2, 3. 1, 3 as well as the 2 to 3 for the second query, right? For the same thing, check for the 3, 4, and 5. So I have shown you for the two queries. How do we calculate? Just carry on with the same. You'll get 0, you'll get 3, 1, 2, 4 for the fourth query, and for the fifth query, you get 1, 2 actually. Yeah. So same process. Just carry on with the same process. You'll get the outputs for the this one, 3, 4, third, fourth, and fifth query actually. Yep. Now we have the understanding of the this one. Basically, what do we call output? See, the output that we have got here is 1, 3, and 2, 2, 3, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct, right? Our approach works absolutely correct here. So let's do one thing. Let's move on with the algorithm summary here, right? So what we will be doing within the code, mainly just listen to this carefully. The same thing will be articulating in the form of code, yeah? So we will process the tree with binary lifting. We will process the tree with binary lifting, yeah? So we will be processing the tree with the binary lifting to get the ancestors FA of this one node J at this one, nothing but the 2 to the power of jth ancestor, right? So just remember, we'll pre-process the tree with this one binary lifting. So mainly we'll be going with the binary lifting to solve the problem. We'll pre-process tree with the binary lifting to get the ancestors. This is nothing but the variable fa of node j. Just remember this, for each node, this one and each j, we will store a sorted list, this one QYY node of QYY of node and j. So this is nothing but the variable name that we'll be considering with the same. Let's go with the same variable name. QYY of node j up to the 10 smallest person, up to the 10 smallest person. Yeah. This one id is encountered on the path from the node 2p 2 to the power of j ancestors. Yep. So this is fine. Next, the final one here is to answer a query, we will lift the nodes to the same depth. We will lift the nodes to the same depth. This is where the binary lifting is very helpful actually. We'll lift the node to the same depth and then we will merge the list while lifting. We will be merging the lists while lifting. Then lift both nodes up. Then we will be lifting both nodes up. Binary lift style until LCA, right? Until lowest common this one ancestor, right? Merging list at the each step, merging lists at each step. So result is the merged list. Result is nothing but the merged list, right? Already sorted. Kept at 10 actually. Print first minimum, nothing but a comma size. So this is what we considered actually min of in the while calculating the query, right? So min of a comma size, that's what we considered, right? So that's the basically algorithm summary I just wanted to show you, right? So you don't have to know everything. Just have the idea, whatever we discussed, right? So that's the idea basically, right? So you'll get to know that one while we write the code. So just you have to know the approach. You have to know how to implement, right? So basically, we'll be making use of the binary lift. So that is the reason I just wanted to discuss about the algorithm summary. That's it. Yep. Now, as we are completely familiar with the approach part, let's carry on with the complexities part, right? So what will be the time complexity here? The time complexity would lead to this one. What do we call? Because this one, what do we call? N plus q logarithmic n effectively, right? So n plus q log n basically. So see, time pre-processing takes big of n into this one max k into 10 actually. We will be going with the pre-processing in the algorithm summary. The first step itself is pre-processing, right? Pre-processing would take up to big of n into max k into 10 for merging, right? So merging. So effectively, it would be big of n log n with a constant less than or equal to 10 per merge, right? Accordingly with the constraint. So each query costs big of max k into 10. That is almost equivalent to big of log n. right, with a small constant. So overall, we have to consider queries as well, right? So this will be big of n plus q log n effectively, right? So overall time complexity would be big of n plus q logarithmic n. So what would be the space complexity here? The space complexity would lead to big of n into max k into 10 plus n for the ancestor arrays that we'll be using. Also, we'll be making use of the stored lists and the adjacency list, nothing but big of n log n with a small context. So overall, we can just consider big of n log n here, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n plus q log n and big of n log n respectively. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just go with here. What dot input output dot star input output package. Also, let's import this one. What do we call utility package? We'll be making use of the different utilities, right? So this is fine. Yep. Now, let me go with public class main. So this is just the class name main. You can just consider any class name that's relevant to the question. Yep. So this is fine. Now, first let's go with a this one variable maxn. Also, let's go with a max k. Maxn is nothing but the maximum nodes. Max k is nothing but the log 2 of maxn, right? So that is almost equivalent to 17 for 10 to the power of 5 or 1e5, right? So I'll just, if we are accordingly with the constraints, we are constrained, right? So I'll just go with the final int. Let me go with the max and let me assign this one to 1 followed by the 4 zeros here and 5. Yep. So also let me consider max k, that is 17, right? So that's almost, as I've said, that is equivalent for this one 10 to the power of 5. So this is fine. Now, after this, let me go with a let's initialize n m and q, right? So the first line they have given n m and q itself here. So this is nothing but the number of nodes. You can clearly see here. These are the edges, right? 1 2 3 4 5 5 nodes we are having. 4 is nothing but the edges m 1 3 1 2 1 4 and 4 5. Yeah, this is nothing but the q or queries you can consider. I'll just consider q, right? 5 we are having 5 queries 4 5 6. So this is first query, second query 1 5 2, 5 5 10 third query, 2 double 3 fourth query, and the final query is 5 3 1 here, right? So this is nothing but the array C, right? So now we have to consider nmq, the first line. Yep. So let me initialize those things. Static n m as well as the q. The next thing is, let's go with this one. Let's initialize fa. Fa of node j is nothing but 2 to the power of jth ancestor of the node. This we have this one discussed within the approach. So let me write this one quickly. Static int. So this has to be, we have to consider two arrays here. This is fine. Fa new int of, so let me pass here maxn. Along with the maxn, let me pass max k here. So this is fine, man. Yep. So now let's do one thing. Let's go with the depth of each node, right? So depth of 0 will be 0 for the demi, right? So I'll just go with the static here. So this one will be int. So this is equivalent to the new int of. So let me go with maxn. Let me go with a maxn. This is fine. Next, I said we went with a QYY of node J, if you remember this one within the algorithm summary. So I said that QYY of node J, this is just the variable name. Don't, so I ask you to ignore at that point of time, right? So that QYY of node J, we have to consider here while writing the code, right? So let's initialize here. So this is nothing but the list up to 10 smallest person IDs on the path from the node up to 2 to the power of j steps. So I can just write it in this way. Static, yeah. So let me go with the array list. So I have to pass the integer. This is fine. Integer, this one array. So let me consider QYY equals new array list. Let me complete the syntax here. So this is fine. So this one, instead of this, we have to go with the size here, right? So let me go with maxn as well as the max k here. This one, sorry. Yep, this is fine now. Now let's go with the adjacency list for the tree. So I'll just go with static. This one will be array list. So this is also fine. Let me go with the integer. Mm, E equals new array list of, let me go with a maxim. So this is also fine. So adjacency list for the tree. Right, so this is fine. Now let's merge two sorted array lists, keeping at most 10 smallest elements, right? So I'll just go with static here. So let me go with the array list. Let me go with integer. Yep, let me go with a merge here. So this one will be array list of integer. So this is also fine. Mm, A. So this one will be array list of again integer. This is fine. Yep. So this is fine. So within the this one merge method, so let's go with one. So this is nothing but we are merging two sorted lists, keeping at most 10 smallest element here. So within this method, first thing here. So let me write the simple this one if condition. So why will so what is the condition mainly? So let me explain you. If empty this sorry, if A is empty, then we have to return B or empty, right? So the same thing goes with B as well. If B is empty, then we have to return A, vice versa. And finally we have to we have to display the result container. These three things, let's do these three things quickly. So if A equals it is equal to value null, A dot is empty. So then what we need to do here, so again, why I if again here, this is fine. Yep. Let me return here. Let me make use of if b equals null, then let's go with a, if it's true, then let's go with a new array list. So this is fine. Else we have to display b. Yep. Next part, if b equals null or same thing, b dot is empty, b is empty, then we have to return a directly. Yep. Then let's go with the result container. So I'll just go with the array list here. So let me pass integer. Let me pass the integer. So this is fine. Just consider VEC. So new array list of a new array list. This is fine. Yeah. Let's complete the syntax. Now we need the pointer into B. We need the pointer into B. So let me initialize P to 0. Yep. So let me write the simple while loop here. Just listen to this. While B less than size of the B. Yep. Well, B less than size of the B and B dot get here of P. B dot get of P. So this is fine. If it is less than A dot get of I. A dot get of I and size of the vector. So this one will be VC dot size. If it is less than 10, then let's add from B while it is smaller. So this one VC dot add dot add b dot get here, b dot get of, let me increment the b here, let me increment the b, right? So this is fine. Now let me write the if condition. What if the size of the vector is less than 10? If vector dot size, if it is less than 10, then let me do one thing. Then let's add the current from A instead of the B. So I can just write it in this way, vector dot add of. So we have to get the value, right? So I'll just make use of the get operation and let me pass I here. Yep. So this is fine. Let me come out of this one entirely. Now let's write the simple while condition, man. While loop actually. While b less than b dot size here. So this is fine. And vector dot size. So this is also fine. Less than 10. Let me do one thing. If any from B remain and space left, then we have to add them, right? So I'll just go with dot add. So let's get this one. I'll just make use of get here. All I have to do is increment the P here, P plus plus. Yep. So this is fine. Finally, let's go with a merged result stored, right? That is stored actually, as both inputs are sorted here in this case. Yep. So I'll just go with the return VC. So let me come out of this one entirely, man. Yeah. So now, mm, fine. Did I miss anything here? Let's continue. So we have to perform the DFS, right? As we had discussed. So let's go with a simple DFS here to set the depths as well as the immediate parent. Nothing but f of this one, fa of x0. Right. So in simple terms, first let me write this one. Let's go with the DFS method actually. Yeah, I need the parameters x as well as the f. So this is fine. So within the DFS, so let me go with the depth of x here. Equals depth of uh, depth of fa of x0. This is also fine. Equals f. Yeah. So this is fine. F plus 1. Yeah, this is nothing but the parent of x is f itself. Yeah, parent of x is f actually. Yeah, depth is parents this one, depth plus 1. Now let's do one thing. After doing this, let's traverse the children. In simple terms, let's move on with the iteration here. In this one, let me go with int I, uh, e of x. So this is fine, e of x. So let me go with the if condition here. If I not equal to x, if I not equal to not x, actually it has to be f. Yeah, f is the parent of x, right? So let's recurse here. I'll just go with the dfs of I comma x. So this is fine, I believe. Now let's move on with the further things here. Next, what shall we do? Let's write the query function that returns the sorted list, nothing but less than or equal to 10 of the smallest IDs on the path x to y, right? So let me go with here static. Oh, let me give array list here and let me pass integer. I'll just go with a method name query. Again, the same parameters x as well as the same actually, not the same as DFS. It's we don't need f here. We need x and y, right? So this is fine. Within this method, query method, let's do one thing. First, let's go with the result accumulator. So I'll just go with the array list here. Again, the type integer. Let me consider result variable res here, but result accumulator. So this one will be new array list. This is fine, man. So the next step would be, let's write the simple if condition here. Let's ensure x is not deeper than y, right? So I'll just go with if here depth of x, if it is greater than depth of y, if it is greater than depth of y, then let's do one thing in tmp temp equals x equals y, also y equals so I have considered tmp variable tmp, right? So this is fine. Yep. So let me come out of this one. Actually, if condition, let's continue with the further things, right? So let's lift the y up to depth x. We are going with a binary lifting, right? Let's lift the y up to depth of x, merging lists from y's jumps. Actually, if you don't know the this one binary lifting, we have already discussed this one within the binary lifting within the this one uh, algorithms playlist, right? You can just go and check there. Yeah, you'll get the algorithm and you can just watch the algo and you can just come. Yeah, so that you'll understand the things quickly. So we are just lifting the y up to the depth of x, merging lifts from this one, lists from y's jumps actually. So I'll just go with a simple for loop int I equals. So let me go with max k here. This one, max k minus 1, I greater than or equal to 0, and let me decrement the I. So this is fine. Next, let's go with a simple if condition. If depth of fa of y as well as I, y as well as the I. So this one, if it is greater than or equal to depth of x, we have to consider, right? Yeah, depth of x actually. Then mm, let me go with the result equals. We have already written merge helper method, right? Merge of. So what are the things that we need to pass here? Result variable. So this one has to be yeah, result. Also we have written uh, not query actually, QYY. So this is fine. QYY of y as well as the j. Qyy of y as well as the, not j actually, I. So this is fine. Yep. So let's do one thing. Let me assign y to fa of y as well as this one I respectively. Yep. So this is fine, man. Let me come out of this one entirely. Now let's do one thing. Let's move on with the further things. Yeah. So if they meet, then we have to include node x's own list. Yeah. So let's do that one. If x equals y, so then return. So let's make use of the merge method that we had written earlier. Merge of result, comma, uh, qyy of x as well as the 0. Qyy of x as well as the 0. Yep. So this is fine, man. X0. Now let's accordingly with the approach in the algorithm summary. So I said we will lift both up until their ancestors diverge. Actually, if you remember, right? If you don't remember that, you can just go rewind the video and you can just go to that part of the video where we had discussed the same thing. Yeah. So now let's lift both up until their ancestors diverge. Actually, let's move on with the iteration pattern, simple terms, right? So this one will be int I equals max k minus 1 I greater than or equal to 0. So this one will be I minus minus. Yep. The next line, let's go with a simple if condition here. If a of y, I, if it is not equal to fa of x as well as the I, then what we'll do? Let me assign result to, I'll just go with a of merge actually. Let me pass again result here qyy of we have to go with the x as well as the I here. This is fine. And also yi we have to go with the right. This one, let me pass y and let me pass I here. Yep, this is fine, man. Somewhere I have done something wrong. This one, this parenthesis I had to close here. Then let me remove one parenthesis from here. Now this is right. Yep, we have just merged both sides lists actually. This is fine. Now after merging both sides lists, let's move up. So that's what we are doing. Moving up means we are lifting both up until their ancestors diverge here. So I'll just give here x equals fa of x actually and I. So this is fine. And also, let me go with y equals fa of y, and this one is nothing but the, yep. So, yep. Now let's do one thing. Now x and y are children of LCA, nothing but lowest common ancestor or lowest common ancestor itself. Now x and y are children of the LCA. Let's include the segment lists to reach the LCA, nothing but the lowest common ancestor. So let me return here. Let me give return. Let me make use of the merge. So this one is merge of result, comma. So this one, q by y of, let me pass here x and 1 respectively, along with the again y0 we have to go with the right. Q by y of y and 0. Yep. So this is fine, I believe. Now we are done with this part, man. So let me come out of this one entirely. Now let's go with the main method actually. Yep. So let me include the main method. So let me remove this. So here, let's do one thing. Let me include throws here. Sorry, throws input output exception, or let's go with a, yeah, let's go with the input output exception. Yeah. So this is fine. Within the main method, let's go with this one, buffered reader, print writer, string tokenizer, as well as the NMQ we have to go with. Buffered reader for the this one, fast input, print writer for the fast output, string tokenizer as we have to read the first line tokens. Then we have to pass N, M, and Q. So we have been given N, see here, N, M, and Q respectively. Let's do that. Let me paste it over here. So this is purely related to the input output. Yeah. So this is not related to the logic. So I have just copy pasted this one. This is fine. So this is fast input again. This is fast for the fast output. this one we have to read the first line tokens, and we have to read number of nodes, number of people, as well as the number of various n and q. This one I'm speaking of again, 545, the first line. Yeah. So this is fine. Now let's move on with the main logical part here. So let's move on with the iteration part. So this one will be for int I equals 1, I less than or equal to n. So this one, yeah. So within the for loop, I'll just go with the e of I equals new. So let me go with the array list here. So this is fine. The next thing, we are just initializing the adjacency list for node I, right? So let's go with one more for loop here. So this one will be int j equals 0, j less than. So we have considered the variable max k, right? So this has to be max k, and let me increment the j. So within this for loop, let's initialize the qy by lists for all levels, right? So I'll just go with a q double y of I and j. Let me assign this one to the new array list. Yeah, this is fine, I believe. Let me come out of this one entirely. Now let's do one thing. Let's move on with a for loop here. Yeah, let's move on with the iteration part. So this one will be I equals 1, I less than n. So this will be I plus plus. So within this for loop, we have to read the edge. We have to go with the endpoint u. We have to go with the endpoint v, as well as we have to add the undirected edge as well. Let's do these four things first. Let's read the edge actually. Yeah. So this one st equals new string tokenizer. So this one will be buffered reader read line. Yeah. So this is fine. Next, let's go with the endpoint u as well as the endpoint v. So this one will be int u equals integer dot parseInt. So this is fine. So dot next token. So this is fine. Yeah. Next, let me copy paste the same thing and just change the variable name here for the this one v actually for the vertex v. Yeah, this is fine as well, I believe. Yep. So Yep. We have went with the endpoint u and v. All we have to do is we have to add the undirected edge here. So this one will be e of u dot what vertex we have to add, vertex v here, and also the vice versa, e of v dot what we have to add here, add u actually. This is fine. Yep, we are done with this part. Let me come out of this one for loop entirely. Now let's move on with the further things. Yeah. First, let me go with the string tokenizer here. We have to read m integers from C1 to Cm, right? So let me copy the same thing yeah, this one, this line, string tokenizer. So let me copy this one and let me paste it over here, right? So this is fine. Now let's move on with the for loop one, the iteration part. Equals 1. So let me increment I here. So this is fine. First, let's go with the city of the person I. X equals integer dot parseInt here string tokenizer dot next token. Yep. So this is fine, I believe. Yep. So this is for the this one, city of the person I actually. Next, let's add the person ID I into the nodes level 0 list. So I'll just go with QYY of X and 0 add of I. Yep. So this is fine. Now let's write the simple if condition here, not of string, this one, string tokenizer has, let me go with more tokens, I less than m. So now let me go with st equals new string tokenizer of so this is fine, I believe. Let me come out of this one entirely for loop. So next, what shall we do? Let's do one thing. We have already written the DFS helper method, right? Outside. So first, outside the main method, I mean. So this one, let's run the DFS from the node 1 using 0 as the dummy parent initially, right? So depth of 0 will be initially kept 0. So let's run the DFS helper method. So this one, 1 comma 0. Yep. now let's do one thing. Let's come to the main part. Let's build the binary lifting table and merge the lists up to this one. Merge the lists for each 2 to the power of j segment as discussed on the approach. So let's go with our two for loops here. J equals 1, j less than, so we have to consider max k. So this is fine. And let me increment the j. Yep. Let me go with one more for loop here. For 1 I less than or equal to n I plus plus. So this is fine. Yep. Next, let me go with the fa of double not I actually, sorry, ij. We have considered ij itself, right? So this one will be fa of f I into j minus 1 here. So this is fine. Into j minus 1. Yep. So this is nothing but the 2 to the power of j ancestor that is equivalent to the 2 to the power of j minus 1 ancestor, right? Of 2 to the power of j minus 1. Yep. So that's what we have done here. So the next step would be, let me write it on this way. Q double by we have already considered. So this one of I, j is equivalent to, let's make use of the merge helper method that we have already written. So this one will be Q double y of I, the same thing, I into j minus 1 here, j minus 1. And also, let me copy the same thing and make the necessary changes here. So this part, we don't have to write the merge again, right? So let me write the same thing here, Q double y of, um, mm, so let me type this one, man. Q double y of, um, fa of, this one, what do we call? I, actually, I into j minus 1. This is fair. And again, to j minus 1 respectively. Yep, so this is fine. So we are done with this part. We have successfully built the binary lifting table and we have merged the list for each 2 to the power of j segment. Yeah, we are done with this part. Next, let's move on with the further things. So mainly we are left with the last thing. So we have come to the end of the this one coding part actually. So let's move on with the iteration part for I equals 0 less than q. Let me increment the I here. Right, so this is fine. We have to read the query. We have to read this one, the query endpoint u. Also, we have to go with the, or we have to read the this one query endpoint v as well, and the max number of IDs to return. These four things actually. Yeah, first this will be st equals new string tokenizer. I should have copy pasted this one. Buffered reader dot read line. Yep. So we have successfully read the query. Then we have to go with the query endpoint u, query endpoint v, as well as the max number of IDs to return u, v, and a respectively. Right. So this one will be int u equals, somewhere I have considered integer dot parseInt. So this one string tokenizer dot next. So this one, this is fine. So let me copy the entire thing here. Paste this one. Let me paste this one. Yeah. So this one will be v, and this one will be a. So this one remains same, integer dot passing. We are passing, so this is fine. So the next part would be here. So let me go with the int here. Sorry, array list we have to consider, right? So we have to get the merged list for the path u to v actually, which is less than or equal to 10. Basically, it's the smallest one, right? So I'll just go with the array list of, let me pass the integer. Yeah, p equals, let me, we have already written the query helper method qry. So let me pass the nodes u and v respectively. After doing this, we have to go with the final number to output, right? So I'll just go with the k. So k equals, so math.1, if you remember the approach, in approach what we did, it is nothing but the a and size we went with, right? So for the size, we'll be considering here p dot size. That's it. Yeah. So this is fine. So the next part would be, so we have to print the count actually. We are left with only the output, this one input output part here. We have to print the count. So I'll just go with the out dot print. So this one will be, k along with within the output we need the space, right? So I'll just give here space. So this is fine. After successfully printing the count, we have to print the first k IDs and we have to move to the new line. So for printing the first k IDs, so I'll just go with a for loop here. So this one will be j equals 0, j less than k. Let me increment say here. So this one will be out dot print. So let me go with p dot get here, p dot get of let me go with a j as well as let me leave space here, right? So we have successfully print the first k IDs. Now after successfully printing the first k IDs, so let's move to the new line. So this one will be out dot print ln. Yep, so this is fine. Final step here would be we have to flush the output, meaning I'll just go with the out dot flush here. So this is fine. So we are done with the coding part. Somewhere I have done something wrong. So let me include one more this one here. Bracket misplacement. Somewhere I have done something wrong. Let's see this one later. So now we are done with the coding part actually. This is fine. Before checking the code with a different this one. Inputs are the examples. Let me copy paste the signature starter template here. So I'll just paste this one here. Yeah. So let me copy this one. We have to get the output this one, right? So let's check the same here. We have many errors, man. So many errors to take care of. 13 errors, yeah. So here, semicolon expected, line number 23. Yeah, let me give the semicolon. This error has to be gone. The next one, identifier expected, static. So this is of the integer, right? All three are of the type int actually. This is fine. Now, yep. So this is fine. While illegal start of type. So let's do one thing. Where is it actually? Line number 42. Mm, within the this one merge helper method, right? So this one where it is p less than p dot size. What's wrong here actually? 1 second. Just give me a second here. So we have written here. So this is within the call. 1 second. Just give me a second here. Oh, what mistake I have done here is I have not included the for loop at all here. B equals 0. So we have considered the pointer into B here. After considering pointer into B, what I have done here, I have directly continued with a while loop actually. I haven't written, we have to basically iterate A here, add the smallest, this one, what do we call that one? Add the smallest interleaving from B actually. That's what we need to do here. So I have written this one, what do we call while loop directly instead of the for loop. So while p dot p less than p size, so this is fine actually. Let me include the for loop as well here. So I'll just go with for I equals 0, I less than a dot size. So this is fine. And dot size. So this is also fine. Uh, less than 10 actually. So yep, this is fine. Let me increment the I. So this is fine as well. Yep. Now this is where actually. Now this is fine. If I run this one, we have many errors, man. Again, 13 errors. Unchecked conversion. So this is warning. Let's ignore the warning for now. Incompatible array type. Array list cannot be converted to the array list of integer. line number 28. So this one I haven't mentioned the array here. Run now. Mm, 4 errors are gone. Now let me ignore this one. Let me ignore this one warning part. Cannot find the symbol. Oh, this has to be size actually. Line number 37. 37 size. Let me run this one now. Left with 7 errors actually. This is fine. Got arrest. Variable I is already defined in the method main string. So line number 91. 91, 91, 91. Method main actually. 1 second. Where is this actually? Yeah, this is fine. For int I equals 1, I have closed the braces here, right? For int I equals 1, I less than or equal to n I plus plus. I knew array less, so this is also fine. For int j less than max k, so this is fine. This is fine. I have closed this one before considering this one. Int I equals 1. So again, I can consider here, right? So the same thing actually within the 100 as well. Equals 1. So we can consider as many times as I want. So I have misplaced the bracket somewhere, I believe, in my opinion. I and J, it is saying the same thing actually here. Return merge. So this is the thing actually. Have misplaced the bracket somewhere. Just give me a second here. So what it is saying here, this one variable I is already defined means do we need to close the this one parenthesis here? 91. If I add one more parenthesis here, so if I run this one now, error class interface enum expected 116 actually. So also here, let's do one thing. Check. So let me change this one actually. For loop. So this one, let me add here. Add here. Let me add one more for loop here. This one. Now if I run this one, this has to be correct. So yeah, we are getting the correct output, right? So 1 2 1 3 2 2 3 3 1 2 4 as well as the 1 2. Yeah, we are getting the correct output. 0. Yep. So that was the bracket one. So overall, actually, bracket misplacement. I knew somewhere I have done wrong. So basically, this one. So here I had to close this one, and I had missed one for loop here entirely. So this part actually, this line itself I had missed. So this is fine. And here I had to close this one. So if I don't close here actually, the entire this thing, this for loop, this the next for loops, all other comes within this itself, this for loop itself, right? So that was completely wrong. That is the reason it was showing. So I we have already used the I, right? I and J basically. That is the that's why it was showing the error basically. Yeah. Now we have closed this one, and again, if we have not made use of this one flare braces, there is no need of this one closing the braces at all. Actually, I had closed one bracket here. So basically, I considered two braces and I have closed two braces. This has to work correctly now. Yep. So bracket displacement was the main thing here. So this is fine, man. Now this is working. Let me copy this one entirely. Come to the submission part. Let me choose C here, Duff in the army, and let me paste this one over. Yeah, this has to work correctly now. Yep, it says yes, sir. So this is fine. Yeah. I hope this works for all the test cases. Let's see. Let's wait for some time. And one more thing, this is going to be the last problem in the graph, this one, graph problems playlist actually. Yeah. And I think we are done with this one, code forces, solving the code forces problems. Yeah. We started with the basically arrays and list. If I remember, arrays, strings, backtracking, linked list, this one sliding window, two pointers. Yeah. Uh, backtracking, recursion, backtracking and the recursion, trees. We have solved many problems on trees. Yep. Um, we have solved the problems on bit manipulation. Yeah. We have solved the problems on segment tree. This one, Fenwick tree, as well as the sparse table. We have solved the problems on the DP, right? So we have solved the problems on graph. Now we have come to the end actually. We have successfully solved the 50 problems. This one. 50 problems on the graph actually. Previously, we had solved 50 problems on the DP. Now we have successfully solved 50 problems on the this one graph as well. Yeah. So we are done with solving the code forces problem basically. I don't know. In the future, I'll be making videos with this much detail actually, right? Slow and with this much detail. I don't know. I think I'll not be making videos for the YouTube. I'll be giving contests. I'll be practicing. I'll be doing every other thing. But for the YouTube with this much detail, I don't know if I'll be able to do or not. So here you can clearly see the toast it is showing accepted. Yeah, the verdict that we got here is accepted. So I'll be continuing with the further things actually. We have to move on with the other stuff as well, right? So we are done with this part. Uh, Today marks the end of solving the code forces problems in detail actually, right? So we have got the opportunity to implement so many algorithms. We learned so many things and other stuff, right? So now we have solved 170 code forces problem actually that covers most of the topics actually. Yeah. So yep, 170 problems is more than enough, man. That's only for the YouTube I have done. I have solved a number of problems or practiced enough, man. In these 5 or 6 years, have solved many problems, right? So yep, this is it for the code forces part actually. 170 problems that I have solved using the Java programming language. And we have solved around 50 problems actually, which includes the topic segment tree, Fenwick tree, as well as the this one, sparse table, and the dynamic programming and the graph in the Node.js also I have done. If someone is practicing or someone is doing the CP in this one Node.js or the JavaScript, you can just check that one as well, right? If you have started doing in the Node.js, you can just check that playlist as well. Yeah, if that's helpful for you, right? So now we have clearly covered most of the topics in a structured way by making use of the Python programming language. Sorry, this one Java programming language, right? So again, we have solved correctly this one 170 problems. We have covered most of the topics, mostly all the important topics, yeah, in a structured way. We are done with this part. So next, let's move on. Instead of the this one code forces problems, we'll be solving the LLD, this LLD problems actually. That's related to the system design. Yeah. So that we will be doing from tomorrow actually. Yeah, that we'll be doing from tomorrow actually. This is fine. So yep, yeah, this was complete fun actually. Solving code forces problem using the Java, it was complete fun actually. I have practiced enough. So yeah, as I've said, I'm confident and I have practiced enough. This was really fun. Let's finish it off with this particular problem. Yep, let's finish it off with this particular problem. In the place of code forces problems, so we'll be solving the LLD problems from tomorrow. Yeah, this is completely fine. Yeah, and again, this is completely based on the LCA actually. The problem is related to the LCA, least common ancestor. We have made use of the binary lifting to solve this particular problem. Yep. So if you are solving accordingly with the me, so solving accordingly with me. So if you don't know certain algorithms, there are algorithms in parallel. We are this one discussing about the algorithms as well. We have come to the end as well, not completely end. We are this one. We are left with almost some maximum 25 to 30 this one all goes actually in my opinion. Yeah, 25 in between 25 to 30 algorithms we are left with. We are uh, going with almost 110 to 120 algorithms, I believe. So in that we are left with almost 25 to 30 algorithms. That's it. Last three topics actually. We have already discussed the main topics, the algorithms related to the graph, DP, linked list, yeah, and this one arrays and strings mainly, yeah. So those kind of algorithms, sliding window algorithms. So these algorithms are already completed actually. Yep. So we are left with number theory algorithms as well as the geometry algorithm, and finally some advanced or miscellaneous algorithms. Yep. So these three parts are left actually. We have come to the end almost in the this one algorithms, this one as well, playlists as well, and also the lead code problems. We have solved around 220 plus algorithms. So there are some 20 to 25 problems left, I believe, or 20 to 30 problems left, I believe. The last 20 to 30 problems left. Almost we are end of this one. Solving the discussing the algorithms, different algorithms, as well as the solving lead code problems as well. And we are done with solving the this one, what do we call, uh, code forces problems. Yeah. uh, Most of the topics we have covered, as I've said, as I'm stressing again and again. If you are really practicing with me, or if you're following, so if you don't know any algorithm, you can just check the algorithms playlist actually. So that I have that we have discussed in the Python. So I can, if you don't know the this one programming language, it's fine, you can just watch the video. This one remains same actually, syntax differs, but approach and other stuff remains the same. Yeah. So you can just check that algorithms playlist. Yeah. So again, we are done with this part actually. Yep, we are done with solving the code forces problems as I had said, right? So we are done with 170 problems, solving 170 problems. Yep. So yep. So the last problem we solved using the binary lifting. This was purely related to the graph and LCA, right? Lowest common ancestor, right? So yep. For now, this is it. Thanks for watching, guys.